The Moon's existence and its interactions with Earth have profound implications for our planet's stability, climate, and the development of life. The Giant Impact Hypothesis. The Giant Impact Hypothesis is the most widely accepted theory for the Moon's origin. This hypothesis suggests that the Moon formed as a result of a colossal collision between the early Earth and a Mars-sized protoplanet named Theia about 4.5 billion years ago. Fission Theory. Proposed by George Darwin in the late 19th century, this theory suggests that the Moon was once part of the Earth and separated due to rapid rotation. However, the energy dynamics required for this event make it less plausible. Capture Theory. This theory posits that the Moon formed elsewhere in the solar system and was captured by Earth's gravity. The similarities in isotopic composition between Earth and Moon rocks make this scenario unlikely. Coformation Theory. This theory suggests that the Earth and Moon formed together from the primordial accretion disk of the solar system. However, it struggles to explain the differences in their compositions. The role of the Moon in protecting Earth. The Moon is not just a passive satellite, it plays several crucial roles in maintaining the conditions necessary for life on Earth. Stabilizing Earth's axial tilt. The Moon exerts a stabilizing force on Earth's axial tilt, or obliquity, which is the angle between Earth's rotational axis and its orbital plane. Without the Moon, Earth's tilt could vary widely, leading to extreme and unpredictable climatic changes. The relatively stable tilt, kept within a narrow range by the Moon's gravitational influence, helps maintain a relatively stable climate over geological timescales. Tidal forces and oceanic life. The gravitational pull of the Moon is the primary driver of tides in Earth's oceans. These tidal forces play a significant role in coastal ecosystems and have influenced the evolution of marine life. The mixing of ocean waters due to tides helps distribute nutrients and supports diverse marine habitats. Shielding from asteroids and meteoroids. The Moon acts as a shield for Earth by intercepting some of the space debris that might otherwise impact our planet. The numerous craters on the Moon's surface are evidence of its role in absorbing impacts. While the Earth still experiences impacts, the Moon's presence has likely reduced the frequency and severity of these events. Slowing Earth's rotation. The gravitational interaction between Earth and the Moon is gradually slowing Earth's rotation. This process, known as tidal braking, is caused by the friction generated by ocean tides. As Earth's rotation slows, the length of the day increases. This slowing effect also contributes to the long-term stability of Earth's climate. Scientific exploration. The Moon has been a focal point of scientific inquiry and space exploration. The Apollo missions of the 1960s and 1970s were monumental in advancing our understanding of the Moon and the broader solar system. These missions provided valuable data on the Moon's geology, composition, and history. The origin of the Moon, most plausibly explained by the Giant Impact Hypothesis, is a testament to the dynamic and violent processes that shaped our solar system. The Moon's role in stabilizing Earth's climate, driving tides, shielding the planet from impacts, and influencing human culture and exploration underscores its significance beyond just being Earth's satellite.